Welcome back to the Deep Dive. This is where we take the information you send us and, well, we really dig into it.
Exactly.
Today, we're jumping way back, Late Cretaceous, Argentina. We're looking at a really interesting little dinosaur called Alvarezsaurus. We've got the scientific info here, the papers, and our mission, if you like, is to figure out what makes it scientifically important. What does it actually tell us about dinosaur evolution?
Yeah, and it's interesting because we're not talking about, a T-Rex or some massive sauropod this time.
Right.
This is a smaller creature, but one that holds some really critical clues, especially about how different theropod groups might be related.
Theropods, the two-legged, mostly meat eaters?
That's them. And Alvarezsaurus lived right near the end of the dinosaur age, so it captures a snapshot of evolution happening then.
Okay, let's get into it. So Alvarezsaurus, it first appeared in the scientific literature back in 1991. Jose Bonaparte, the paleontologist.
That's the one, a very famous Argentinian paleontologist. And the name itself, Alvarezsaurus, is actually a tribute.
Oh yeah, to who?
Bonaparte named it after Don Gregorio Alvarez, who was a historian from Neuquén province in Argentina where the fossils were found.
Ah, okay. And the specific location was the Bajo de la Carpa Formation.
Correct. Bajo de la Carpa Formation, Argentina. That puts it somewhere around 86 to 83 million years ago. Late Cretaceous.
So Late Cretaceous, Argentina. What kind of place was that? What was its world like?
Well, the formation suggests, river systems, floodplains, a world definitely still dominated by dinosaurs.
Right. And Alvarezsaurus itself was, well, pretty small, wasn't it?
Oh, definitely. We're talking maybe 3.3 to 4.6 feet long, something like that.
Wow, okay.
And maybe weighing around 6 or 7 pounds.
So like a large house cat, maybe?
Yeah.
But a theropod.
Mm-hmm.
So related distantly to the big guys like T-Rex.
Exactly. It's a theropod, so it walked on 2 legs bipedal, and based on its leg structure, and it had a long tail for balance.
Right, so balance.
It was likely pretty agile, probably quite fast, like other small, lightweight theropods. Good bursts of speed.
Okay, and this is where the anatomy gets kind of specific and interesting. The tailbones, the vertebrae, they were unusual.
Yes, the caudal vertebrae. They had some distinct features. The main body of each vertebra, the centrum, it was sharp on the bottom edge.
Okay.
And the bits sticking out sideways, the transverse processes, were sort of triangular and pointed outwards and back a bit.
And that matters because...
Because we see similar features in another Alvarezsaurid, Cuvier. It hints at a shared evolutionary path there, a connection.
Gotcha. What about higher up the spine or other bones? Anything else stand out?
Well, yeah. Those bony spines that usually stick up from vertebrae, the spinal processes, they were apparently missing or really small on its tail vertebrae. And the connectors between vertebrae, the presicapophyses, were short. Little details, but they tell us about how flexible its tail might have been.
Okay, and moving towards the front, the shoulder blade. Scapula.
Right, the scapula. It was noticeably curved and actually proportionally smaller compared to what you see in some other later Alvarezsaurids.
Suggesting maybe different arm use or posture?
Possibly. It might hint at differences in how the forelimbs were evolving within the family.
And speaking of differences, here's one the sources highlight. Its ankle bones.
Right.
The astragalus and calcaneum weren't fused.
Yes, and this is really key. In many later Alvarezsaurids, like Mononicus and Cuvier, those bones are fused together.
Right.
The fact they aren't fused in Alvarezsaurus suggests it's more primitive, more basal. It's showing us an earlier stage before that fusion, which probably helped with ankle stability later on.
So it's like watching evolution in progress through the family tree.
Pretty much, yeah. It's a great example.
With the feet. The feet sound like they were really quite weird. The metatarsal.
Oh, absolutely. The foot bones. So like in most theropods, the middle one, metatarsal 3, was the longest. That's normal.
Yeah.
But in Alvarezsaurus, metatarsal 4, the one next to it heading outwards, was also unusually long, almost as long as number 3.
That is odd. Does that suggest anything about how it walked or ran?
It definitely suggests something different about its locomotion, or maybe its stance, compared to relatives. It hints that maybe not all Alvarezsaurids were doing exactly the same thing, ecologically speaking.
Right. So we have this picture of a small, fast dinosaur, unique tail, unique feet. What did it eat? Any ideas?
Well, the hypothesis often mentioned is that it might have been insectivorous, an insect eater.
Based on?
Mostly its small size. And while the sources we have aren't super detailed on its forelimbs, Later, Alvarezsaurids developed these incredibly weird, strong, single-clawed
Right,
hands.
like Mononicus, thought to be for tearing into termite mounds or something.
Exactly. Alvarezsaurus probably wasn't that specialized yet, but being small and agile fits the profile of something that might have chased down insects or other small invertebrates.
Okay, that makes sense. Let's zoom out a bit then. Where does Alvarezsaurus sit in the bigger dinosaur family picture? You mentioned basil earlier.
Right. Basil within the Alvarezsaurid family. That means it's sort of closer to the common ancestor of the group. It branched off earlier than things like Mononicus or Shibuya.
So it shows us what the earlier Alvarezsaurids were like before they got some of those more extreme features.
Precisely. It gives us clues about the starting point for this lineage.
And this whole family, the Alvarezsauridae, they've caused a bit of head-scratching classification-wise, haven't they? Were they birds? Were they dinosaurs?
Oh, yeah. That's been a big debate. Their skeletons are just odd in many ways, especially those arms.
Right.
So for a while, some studies actually suggested they might be really closely related to modern birds, the new ornithins, or maybe even flightless birds themselves.
Wow, really?
Yeah, it was a pretty controversial idea, though. As more fossils came to light, the consensus shifted more towards them being definitely theropod dinosaurs, just a very specialized branch. But the bird connection debate was real.
And wasn't there also a shift in thinking about where the earliest Alvarezsaurids came from? Weren't the South American ones, like Alvarezsaurus, thought to be the first?
That was the thinking for a bit, yes.
Yeah.
The Patagonian finds seemed the most primitive. But then came the discovery of Haplocharis in China.
Ah.
Haplocharis is even older late Jurassic and even more primitive, more basal than Alvarezsaurus. It has some early Alvarezsaurid features, but also lots of general theropod traits.
So that discovery pushed the origins of the group further back in time and to Asia.
Exactly. It really changed the picture of their early evolution and geographic spread. It showed the Patagonian ones weren't the absolute earliest branch.
Okay, so just to make sure we've got the labels right for Alvarezsaurus,
Right.
how does the formal classification go?
Okay, let's run through it. Domain Eukaryota, Kingdom Animalia, Phylum Chordata, then Dinosauria, Saurischia, Theropoda, and within that, family Alvarezsauridae.
And the genus and species?
Genus Alvarezsaurus, species Cowboy. So Alvarezsaurus cowboy, named by Bonaparte in 1991.
And there was a note about a possible synonym, Achillosaurus.
Right. Achillosaurus is another theropod found in the same formation, named later in 2007. There's been some suggestion, some debate, that maybe the fossils assigned to Achillosaurus actually just belong to Alvarezsaurus. It's not fully settled, but worth noting.
Okay, got it. So wrapping our heads around Alvarezsaurus, we've got this small, likely quick theropod, Late Cretaceous Argentina, named for a historian. It had some really distinctive features, especially that tail structure and the weirdly long fourth metatarsal in the foot.
Very unique combo.
It sits at the base of its family tree, the Alvarezsauridae, giving us clues about their early evolution.
A really important window into that group.
And its broader classification, where it fits relative to birds, has been, well, a moving target in paleontology.
Absolutely. A great example of how science revises its understanding as new evidence comes in.
And it's just amazing to picture this little creature running around in that late Cretaceous Argentinian landscape alongside presumably much larger dinosaurs.
It really paints a picture, doesn't it? Adds another piece to that ancient world's puzzle.
Yeah. And that kind of brings us to a final thought for you listening. Just think about how discovering and studying a dinosaur that was, maybe only 4 feet long,
Pretty tiny in the grand scheme.
how that can spark such big questions and force us to rethink major parts of dinosaur evolution, even their connection to birds. It shows every fossil, big or small, can potentially rewrite history.
It really does.
So maybe dig a little deeper into the Alvarezsauridae yourself, or just keep exploring the incredible story of theropod evolution. Thanks for joining us on this deep dive.